there is a word about cardiac cycle. I think in B.Pharm syllabus also you have studied about cardiac cycle. Let us see about this cardiac cycle. Now see, when you understand how the circulation is going on in the heart, cardiac cycle will become very easy. Let us start one by one. Now, see, we'll start with atria. At the initial stages, atria will start contracting. See, let me erase these things so that things will be clear. Okay. So at the beginning, what happens is atria undergoes systole. What do you mean by atria systole? Both the atria contracting. What happens when atria contract? The blood has to come down to ventricle. When it will come down? When these valves open. When atria is under systole, atrioventricular valves open. So both of them will contract, both the valves will open. What happens then? Blood rushes to that ventricle. So ventricular filling occurs. Ventricle fills. So this is how the cardiac cycle starts. Atria undergoes systole. The valves will open, ventricle fills. After that, what happens? Now, all the blood is in ventricle, right? All the blood comes down to ventricle. Now, once it gets into the ventricles, the valves will close. Atrioventricular valves will close. AV valve closed. So these valves are closed. Next, ventricle contraction occurs. So what is that? Ventricle systole. Ventricle systole. Now understand the word. Now these valves are closed. Now ventricles undergoes contraction. When ventricles contract, what happens to the blood? From this right ventricle, blood should reach to pulmonary artery. From here, the blood should reach to aorta. But there is a time lag to open this pulmonary valve and aortic valve. Unless the valves are open, blood cannot go there. Now what happens is there occurs a time wherein all the valves are closed, but ventricle is trying to contract. This is known as IsoVolumetric contraction. Understand this word. Now, IsoVolumetric means there is no change in volume. Whatever the blood is there in the ventricle, the volume remains as such. Why? When these valves are open, blood will be pumped out of the heart. Because all the valves are closed, whatever the volume of blood is inside the heart, it remains as such. It is called as IsoVolumetric. But what is happening with ventricles? They are contracting. This is for very, very limited amount of time, but that particular period is known as IsoVolumetric contraction. What happens after that? Now, immediately after that, the pulmonary valve, aortic valve, both of them will get open. Pulmonary valve and aortic valve opens. What happens when both the valves are open? Because of this contraction, blood will be ejected out of the heart. So blood ejects. Blood ejects out of the heart. This is the next phase. Now blood is reached to pulmonary, lungs, as well as to aorta. What happens after that? Now the last stage. Once blood is reached out of the heart, now all valves will close again. All valves close again. So these pulmonary valves are closed, atrioventricular valves are closed again. Then ventricle starts relaxing. That is ventricular diastole. Now see what has happened. All the valves are closed, ventricle is relaxed. When the valves are closed, there is no change in blood volume. Again, it results in a condition called as IsoVolumetric. What is happening with ventricle? It is under diastole, that is IsoVolumetric relaxation. So this is what happens. Now after this, again it moves to, again, atria undergoes systole, atrioventricular valve opens, and then blood comes down. This is known as cardiac cycle. Let me explain it again. See, it continuously moves in a cyclic fashion, hence it is known as cardiac cycle. Briefly, what it explains is how the blood circulation occurs in the heart. It all starts with atria contraction. When atria contracts, the valves opens, blood comes down. Right. After that, when ventricle contracts, the valves open and blood will be, from here it is going to lungs, from here it is going to aorta. This is what separated in next steps. The first step, atria contracts, valves open and the blood is coming down. In the second step, the atrioventricular valves are closed. Valves are completely closed, but the ventricle starts contracting. That is ventricular systole. There is a brief period of rest wherein blood is not going out because all the valves are closed. There is no chance to go out. The volume of blood is not changing, but ventricles under contraction. That condition is known as IsoVolumetric contraction. Understand that word, IsoVolumetric. There is no change in volume of blood, but ventricles under contraction. After that, the pulmonary valve and aortic valve opens. When it opens, the blood rushes into that zones. Pulmonary and aortic valve opens, blood ejects. Blood is moving out of the heart. After that, again, the pulmonary and aortic valve closes. All the valves will be closes. Then ventricle will undergo a diastole, relaxation. When ventricle under relaxation, blood cannot go anywhere because all the valves are closed. This phase is known as isovolumetric relaxation. After that, again, atrial systole occurs. This is how the heart works, and this is known as cardiac cycle. A very simple thing. When you understand how the circulation goes on, you can easily get this. You know, cardiac function can be ascertained by electrocardiogram, ECG. I'll explain in detail about electrocardiogram, but understand certain things here. When you see ECG, there is a P wave, and then you have a QRS wave, and then you have a T wave. So this is how ECG will be. You have a P wave. This is called QRS complex, and this is T wave. Right. So the P wave represents atrial systole. So at this phase, you have T wave is there. Now after that, the ventricular systole is there. Ventricular systole is with QRS complex. Ventricular systole is in QRS complex, and the T wave represents phase 1. So the PQRST is related to this cardiac cycle. How that inflection occurs? It is because of ionic changes inside the cardiac cell. Again, remember, the P wave represents atrial systole. QRS complex represents ventricular systole, whereas T wave represents ventricular diastole. Now see, we are talking about ventricular systole and ventricular diastole. Atria, once it undergoes systole, it also has got ventricular diastole. The diastole will come here, ventricular diastole, that will be merged in this QRS complex. Because of this high inflection, you cannot see that it is inside there. We'll see it again, but let me brief out and relate this concept with ECG. So the PQRST represents systoles and diastoles of the heart. The P, atrial systole, QRS, ventricular systole, T, ventricular diastole. So this is about cardiac cycle. When you understand the circulation, it becomes easy to understand cardiac cycle. Now, once it is clear, we can move on to another thing. So all these things are physiological aspects, but these terms are important ones. One of my old students said, there is a question about isovolumetric relaxation in NIPER examination. So see, this part relates to physiology, but when you understand that word, you don't need to memorize anything. Think about that word, you will get everything. Systole, diastole, isovolumetric. Okay, the next thing. You know, our heart has got sounds. Technically, we call them as Lubb Dubb sounds. Lubb and Dubb. You know, these sounds are made because of these valves. When the valves close down, we get the sounds. The first sound is because of AV valve closure. You know, what happens when atria contracts? AV valves opens, blood rushes into the ventricle. After that, atrioventricular valves closes. When they closes, it gives a sound. That is what is Lubb sound or the first sound, AV valve closure. Now the next sound is because of pulmonary valve and aortic valve closure. You know, this pulmonary valve and this aortic valve, when they close, they give the sound tap. So hard sounds are because of valve closures. The first sound or Lubb sound is because of atrioventricular valve closure. The second sound, tap sound, is because of pulmonary and aortic valve closures. So this is, see, what we